5.4 is polygons, and then we're taking a test.
Today?
So, no, not today.
Wow.
Your test is probably going to be on February 21st, which is next Thursday. All right, so 5.3 triangles. Our learning goal is students will be able to find the missing angle measure in a triangle. Before we even start, does anybody know how much the angles inside a triangle have to add up to? There's 3 angles inside a triangle. How much do they have to add up to? Good, they have to add up to 180. All right, let's go over some vocabulary. You guys have the guided notes right in front of you. So let me talk about some vocabulary. It's a little small, so if you want to draw more of a picture next to it, feel free. So a triangle is a figure that's formed by 3 line segments. It intersects at their end points. A triangle can look like that. It could look like that. It could look like that. All right, those are all examples of triangles. Next, interior angle. What does interior mean? Inside. So an interior angle are all the angles that are inside the triangle. All 3 of the angles have to add up to 180 degrees. So the inside has to add up to 180. So 90 plus 60 plus 30, that works. That triangle adds up to 180. We also have exterior angles. So, exterior angle, what's exterior mean?
Outside.
Outside, okay? So exterior angles are on the outside. So here's an example of an exterior angle right here, that X. So it is formed by one side of the triangle and the extension of an adjacent side. So here we have our triangle, and then we have X. We have that exterior angle. This picture is labeled and it's pointing to it, saying that the X is the exterior angle. It's on the outside. What is special about those 2 angles? They make a what? Very good. They make 180 degrees together. So if we wanted to figure out X, we could do what? 180 minus 58. Nice job. And the bottom. The last vocab word you have is a remote interior angle. Now there's this special rule for remote interior. Each exterior angle has 2 of these that are not adjacent. Okay, so here's my exterior. That might sound a little weird, so let me explain what I mean. Alright, so here's my exterior angle out here. What it's saying is that every exterior angle has 2 remote interiors. So those are the 2 inside the triangle that aren't next to it. They're not adjacent to it. They're not touching it. If we look at this example, this was our exterior, right? That X that I just made yellow. What are the remote interior? Which ones are they? Good, Y and 60, because they're not touching it, because the 58 is touching it. That's adjacent. But the Y and the 60 that are in yellow now, they're not touching it, but they're interior. They're inside the triangle. And we're going to come up with some rules for that and why that's important. All right, so we are going to review some triangle classification here. So we can talk about triangles 2 ways. We can talk about it based on their angles. We can talk about them based on something else. Sides. Josh had it. Good. So we can talk about it based on angles or sides. What about angles? What kind of angles do we know about? Josh. Acute angles. Acute angles are so cute because they're little. They're cute little angles. And when I say little, what number do they have to be less than? To be acute, Amreen, Very good. So you might want to draw yourself a little picture. Here's my, oh, I guess yellow might not be the best color. I can change for the next one. But that's an example of an acute triangle. All three of those angles are smaller than 90 degrees. All right. The opposite of acute is obtuse. So obtuse, inside a triangle there's a rule. There can only be one obtuse angle, and the other two have to be acute. Does anybody know why? Right, they have to equal 180. So can I have one angle that's 91 and another angle that's 91? That's already what? 182, and I need three angles for a triangle. Okay, so here's an example of what an obtuse, actually, it's okay, we'll say it's obtuse. I should have made this more obtuse, so it doesn't look right. But here we go, right here, that's my obtuse angle, and the other two are acute. And lastly, so types of angles, acute, obtuse, and a right angle. How much does a right angle equal? A right angle? Thank you, 90 degrees. So here's my example. Sometimes it'll have that symbol. That symbol tells you that it is 90 degrees, and it makes a right triangle. A right triangle. It doesn't always have to be in the corner like that. Sometimes it could look like this. That is still a right triangle. A right triangle has one that's 90, and the other two are something else. What do the other two have to add up to? 90. The other two have to add up to 90, because this is 90. The other two together have to add up to 90, because a whole triangle is 180.
So those other corners can be more than one a number, like it can be 60 and 30,
Yeah.
It could be 30, whatever.
Yep, so they just have to add up to 90, so she asked a good question. If this one right here is 90, right here, this could be 60, that could be 30, 45 and 45, 80 and 10, just depending on, it just has, both of them together have to add up to 90.
Okay.
Okay. All right, and then we talk about triangles based on sides. There's three ways to talk about them based on size. The first way is scalene. That means that all three sides have different lengths. So your triangle might look like this. Okay? All three of them are different lengths. So this might be 3 inches, 5 inches, 6 inches. Okay, they're all different lengths. That's what scalene means. All the sides are different lengths. The next one they ask about on IXL in O2 a lot. The next one is isosceles. Isosceles are interesting because usually it looks like this. Okay, and two of the sides are equal. So we use these little marks that we're not really sure if they have a special name, but we just call them tick marks. So because this has one and that has one, they're isosceles. And that's saying that this side is equal to this side. So if I told you the left was 10, how much is this side? 10. Okay? So on IXL, just to give you a little preview, what they're going to say a lot of the time is they're going to say you have an isosceles triangle, and one of the angles is 100. What are the other two angles? So if this one is 100, which it does not even look like 100, so that was a bad number for me to choose, but it'll say if one of them is 100, what do the other two have to be? So if these two sides are equal, the two angles are going to be equal. they would each have to be 40. Good, thank you. And then the last kind that we have, did you want to add anything else to that? Okay. And then the last one is equilateral. Equilateral triangles are special because every single side is the exact same. And with that said, every side is the same, and guess what's special about the angles, Isel? So on an equilateral triangle, yeah, usually they're all equal. So what do they have to be? If they're all equal, there's only one number they can all be. Thank you, Jaden. And they all have to be 60. Because 60, 60, 60 is 180. Okay, for our first example, it says interior angles in triangles have a sum of, which we already talked about, Jackie, 180 degrees. Good. So if I was given this triangle and I want to write an equation, what equation would I write? Amreen?
90.
Using this triangle that's up on the board. Yeah. Good. This angle, which is x, plus y, plus z, is equal to 180 degrees. That is our equation. We want to get in the habit now of writing equations for our triangles, okay? Sometimes they're going to be really easy where you can do 180 minus 70 minus 30 to get that missing angle, right? But sometimes we're going to have variables in for our angles. So you're going to want to be able to write equations, okay? All right, so let's do an example together. Find the measure of x. Who can tell me, first and foremost, something that's very important in this picture that you're going to use? Alyssa? 55. Okay, we have 55.
And 90.
We have this little box here, which means 90 degrees. I highly recommend you get in the habit of writing 90 degrees as soon as you see that, because a lot of students forget that angle, okay? So you're going to tell me what my equation is going to say. Jackie? 55 plus x plus 90 equals what? Yes, 180 degrees. What is my first step in solving this equation? Ijo?
Combine like terms.
Yes, what are my like terms?
90 and 55.
55 and 90. What's 55 plus 90? Everybody? 55 plus 90? 145 plus x is equal to 180. I want to get x by itself. What do I have to do? Subtract 145. And what is x equal to?
35.
X is equal to 35. So that means this angle is 35 degrees. Example 2 says find the value of x, then find the value of each angle. This one's not as easy as the last one because we don't have two measures that are given to us. We have to find the value of x first. Who can tell me what my equation is going to say? Tatiana?
X plus 10
Good. We have x plus 10
plus 2x plus 30
plus 2x plus 30 plus x equals, 180 degrees. Excellent job. Kai, who can tell me my next step? Hannah?
Combine like terms.
What are my like terms?
10 and 30.
I have positive 10 and positive 30, which gives me
40.
Okay, what else do I have alike?
2x.
I have 2x,
And then x and x.
x, and x, which makes how many x's?
4x.
Plus 4x is equal to 180. Excellent job. What's next? Amreen?
Subtract 40.
Subtract 40 from both sides. I have 4x is equal to 140. Final step, Hazel?
Divide by 4.
Divide by 4, and x is equal to? 35. Am I finished this problem?
No.
No. The directions say find the value of x, which I did. But now I want to know how many degrees is each one of my angles. So I need to do what? Substitute in. What do we always say? Substitute in? Solve.
So x plus 10, or 35 plus 10 is equal to? So this one is 45 degrees. 2 times 35 plus 30 is 100 degrees. And this one's going to be 35 degrees. Is there a way for me to check my answer to make sure that I'm correct? Add them all up. 100 plus 35 plus 45 equals 180 degrees, which we know is correct. If I get something higher or lower than 180, I know that I did something wrong and you should go back. Turn to page 390, do letter A. 34 degrees is correct. You do 180 minus 72 minus 74 to get 34 degrees. All right, moving back to your notes. Our next example is a little bit more complicated, but once you see how it's done once, you should be good from that point forward. It says the measures of the angles of triangle ABC are in the ratio 3 to 6 to 9. What is the measure of each angle? Anybody have any idea? Take a second, think about any ideas how we can set up the equation based on this ratio. So you write an equation with the ratio 3 to 6 to 9, 3x plus 6x plus 9x equals 180. You solve for x, which x is equal to 10, and then you substitute them in using a table to find the three angle measures, which are 30, 60, and 90. The measures of the angle of the triangle EFG are in the ratio 2 to 4 to 4. What is the measurement of each angle? Who can tell me my equation? Kaylee? 2x plus 4x plus 4x equals 180 degrees, because we're using these as our coefficients. When I combine like terms, Mikkel, what do I get? 10x is equal to 180. Divide each side by 10. What is x equal to? 18. So now I'm going to make myself a little table. Okay, and as 2x is one angle, 4x is another angle, 4x is my third angle. So 2 times 18 is 36 degrees for one angle. 4 times 18 is 72 degrees for my second angle. And my third angle is also 72 degrees. So these are my three angles in this triangle. Does anyone know what kind of triangle that's going to be if two of the angles are the same? It's going to be an isosceles triangle. Very good. Turn to page 391, do letter B. So the measures are 30, 60, 90. Oh, 30, 60, 90. I know that two of the examples we've done have 30, 60, 90 degrees. They're not always like this, so don't get in the habit of writing 30, 60, 90 when they give you a ratio.